Hello, my name is Steve Bowler, and in this video we're going to be taking a look at Border Gateway Protocol, otherwise known as BGP. In particular, within BGP we're going to take a look at BGP Route Aggregation. We're also going to take a look at BGP Route Dampening, and then the last thing we'll look at is how to configure BGP Suppress-Maps and Unsuppress-Maps, or how to configure suppress maps and unsuppressed maps within BGP implementation. And we're going to be using in this lab a frame relay switch between R1 and R2. We're going to right click on the frame relay switch. We're going to name this FRS, or short for frame relay switch, and we're going to go in and create our DELCs. Port 1 is going to be mapped to DELC 102, and DELC and port 2 is going to be mapped to DELC 201, and map that, and we'll hit apply and OK. So the next thing, we're going to click on the links. We're going to click on R1. We're going to click on the frame relay switch port 1, which is going to be DELC 102, and then for router 2 we're going to be using a serial connection from R2 to the frame relay switch. We're going to be hooking into port 2. Port 2 is mapped again to DELC 201. So now that we have the DELC connections mapped from the routers to the frame relay switch, we'll go ahead and start the router and create our frame relay connection on the routers. So we will go ahead and console into router 1 and configure router 1 first. We're going to we'll give router 1 the host name of R1. We're going to create a loopback 0 interface on R1. Give it the 192.168.10.1 IP address. We'll give it a /24 subnet mask, and then we will go into our serial interface connecting R1 to the frame relay switch. We're going to set the encapsulation to frame relay since we are connecting to a frame relay switch. Now we're going to go into the sub interface, which is going to be using serial 0-0.12, which simulates our connection from router 1 to router 2, and then we're going to be using a point-to-point frame relay connection. Now that we're under sub-interface mode on the interface, we're going to be using the 172.16.1.0/30 subnet range. So for router 1, we're going to give it the 172.16.1.1 IP with the /30 subnet mask, and then we're going to put in frame relay interface DELC 102 to specify our DELC to use on this point-to-point sub-interface. And now if we go back to interface serial 00, we will do a no shut on the interface. And we're going to do the same thing now on router 2. So let's go ahead and console into router 2 and get it configured. So again, we're going to configure the host name first of R2, and then we're going to go under loopback 1, or we'll create all of our loopbacks real fast. Loopback 1 is going to be the 192.168.1.1/24. Loopback 2 is going to be using the 2.1/24. Loopback 3 is going to be using the 192.168.3.1/24. And loopback 4 is our last loopback on R2, and it's going to be using the IP address of 192.168.4.1 with a /24 subnet mask. So now that that is all done, we will go under our serial connection to router 1. We're going to specify encapsulation frame relay because we are connecting to router 1 via the frame relay switch. We're going to go under our interface serial 00.12 and we'll specify point to point for our frame relay subinterface type. We'll put in the IP address of 172.16.1.2 with a /30 subnet mask, and then we're going to tie in our delc that we created to specify in the local router, which is frame relay interface delc 201, because that's what it is set up on the frame relay switch. So now let's go under the physical interface and we will do a no shut under the physical interface on R2. So as we can see, we have a very simple network topology in this video. We just have router 1 and router 2. We're going to demonstrate a couple things in BGP for you. If we do a simple ping, we can ping now to router 1. So now let's go ahead and get our BGP configuration up. On router 2, we're going to be running on router 2 we're going to be using autonomous system 200. So we'll go router BGP 200, and then we're going to specify our neighbor that we're going to be peering with, which is router 1. We'll specify the remote AS of 100, and then again for the neighbor we're putting in 172.16.1.1, which is R1's IP address on the serial interface, or the sub interface. So now we have to create R1's BGP connection to router 2. We'll go into router BGP 100 because that's the local AS on R1, and we'll do 172.16.1.2 with the remote AS of 200. So we have an external BGP connection between R1 and R2. We're going to advertise also on R1 the network of 192. Actually, we'll do no auto summary. So that we can advertise our subnets within BGP. We'll do no synchronization. We'll do this on both routers. And now I can go under router 1 and do a network 192.168.10.0. And then on R2 we're going to advertise our loopbacks into BGP for autonomous system 200. So we got the 1 network, the 2 network, the 3 network, and finally we have the 4 network that we are advertising. So if we do a show IP BGP summary, we have our BGP connection up for about a minute now, which is router 2 in autonomous system number 200. So now if I do a show IP BGP, we can see the networks that we have advertised into BGP on both routers. If I try to ping 1.1, which is R2's loopback 1, I have connectivity. Same thing on router 2. If I do a show IP BGP, I can see the 10 network that I am advertising on router 1. So if we try to test connectivity, we are successful. If we try to test layer 3 reachability. Okay, so the next thing we're going to take a look at is BGP Route Aggregation. As we can see on router 2, we see that we have 4 networks. They're all Class C networks, and we're advertising them to router 1, which is in AS 100. So router 1 is seeing all these networks that router 2 is adding into BGP. So what we can do via BGP Route Aggregation is summarize these routes and send them to router 1 so that router 1 is only seeing 1 network instead of 4 being advertised by router 2. We do this on router 2 by using the aggregate address command. because router 2 is where we're going to be performing the aggregation. We'll go under BGP, again for Autonomous System 200, and we type in the command aggregate address. And this is where we're going to type in our address in which we want to summarize. And then we're going to be advertising the range of 192.168. Actually, what I did was I paused the video and I changed our networks that we had on R2 so that we can work more efficiently. So we changed it from 1234 to 0123 so that we could aggregate or summarize these networks in a more efficient manner. We'll do this with the network aggregate address command of 192.168.0.0 with the 255.255.252.0 subnet. Again, this is going to be a, if we go ahead and hit enter, so now let's go back to router 1, do a show IP BGP. We can see that router 1 is now seeing the aggregate address that are the summary that we are sending. So we are seeing inside of this /22 the 0, 1, 2, and 3 Class C networks. So we can do this and leave it with that. If I do a show IP route, now our routing table is showing all the /24s and the aggregate route, which is the /22. So in this scenario, say our customer just wants the aggregate, we can go under router 2 and we can specify after the IP or the network and the subnet, we can add in the summary only command. And we can see now we can only see a summary being propagated from R2 to R1. So we have successfully aggregated this address range of 0 through 3 to R1. So again, this is going to, what this will allow us to do is, if you think about BGP, it scales the internet. I mean, if you think about all the service providers with all these more specific subnets, the routing tables are going to be huge. So a lot of times the service providers will not accept these more specific subnets, so we're going to have to aggregate them. So on router 2, if I do a show IP BGP, we can see the summary route that we created, and we can also see the S next to all these other networks. And this S is telling us that these networks are being suppressed, or they are not being sent in our BGP routing updates on router 2. Okay, now suppose that our customer on router 1, say he wants aggregation to be performed, but he wants to also be able to see the 3.0/24 subnet to show up in his BGP topology table and routing table. So say he's doing some route manipulation on that specific network. What we can do is create a suppress map in this instance that will take this network away from being aggregated and send it as well to router 1 along with these /22 aggregate. We can go ahead and do this by going to router 2, and we'll create a simple standard ACL. So we'll call it access list 1, and we will deny 192.168.3.0, again 0.0.0.255 for the wildcard. And then we're going to do an access list 1 permit, any, because we still want the aggregation to be performed on the other networks. So we want to deny the 3 network from being summarized, or being aggregated in this case. So we're going to go and create a route map on router 2, and we're going to call it suppress. And we're going to add a permit statement. We're going to match IP address, which is going to be IP address 1, which this is our access list 1 that we just created. So now if we go under router BGP 200, we will do the command aggregate address 192.168.0.0 255, 255, 250, 252, summary only. And after summary only, we're going to specify our suppress map. So we're going to filter more specific routes. So basically router 1 right now, if we do a show IP BGP, it's only seeing a /22. So we're going to populate the 3 network inside the BGP table on R1 as well. So we'll do summary only, and then we're going to put in, after summary only, we're going to put in our suppress map, which is the route map that we just created, which is suppress. So what do you think? Is router 1 going to have that in there or not? As you can see, it is not yet, because with BGP there are certain things that will not be updated to our peers unless we do a clear on the peer. Unless we do we'll do a soft clear on the neighbor. So in this case so whenever we do stuff with the route maps, our access control lists, any type of filtering or route manipulation, it's really a good idea that you clear the neighbor that you're trying to perform this task on. So in this case, we're going to clear router 1. I'm sorry, not 192.168. It's going to be 172.16.1.1, and then we'll do a soft after the clear. So this will not allow for the BGP neighbor relationship to bounce if we just do a soft clear. So if we do a show IP BGP, we can see now that we are still not seeing it. So it looks like we messed up the aggregate address statement. We specified a /30 instead of the /22. So that will mess things up. So let's go ahead and go back under BGP configuration mode, and we will fix this. We'll do the up arrow, and we will do a no in front of that command, and then we will go back and take out the no, and then we are going to move and take this take off the /30, and we will do a /22. So we'll go ahead and hit enter, and this should work. So again, on R1, if I do a show IP BGP, that time we did not need to clear the neighbor, and what we are seeing now is that our suppression has occurred properly. We are now seeing the 3 network being advertised to router 1, and the other networks are covered under the /22, but the 3 network we successfully used a suppress map to allow this network to be sent, even though it is covered under the /22 aggregate network. We can also create what's called an unsuppressed map, and this unsuppressed map will do the exact opposite of what a suppressed map does. So what we're going to do, and to show you this, we're going to create the unsuppressed map on R2. We will do a no access list 1, and then we'll create a new access list, which is going to be access list 1 permit 192.168.3.0 with a 0.0.0.255 wildcard bit mask. So last time I was denying it from being suppressed, and now I'm permitting it to be unsuppressed. So let's go back under BGP, router BGP 200. And we're going to take this aggregate address command off. What I'm going to do now is blow away the suppress map that we created. We'll enable this command again, and instead of we're just going to take the suppress map option off. And the unsuppressed map is created under the neighbor statement going to the router. So in this case we're going to do, before we do this, let's take a look at router 1's. If we do a show IP BGP, we make sure that the 3 networks are not being advertised anymore. Now it looks like they are all being advertised. So let's go back to router 1 and do a show IP BGP. Looks like we're not seeing the aggregate. For some reason, the aggregate was also, when I did a no aggregate address, that aggregate, that summary, was taken out too, so I had to go ahead and add that. So now I can see the /22 being advertised to router 1. What we can see is that we created so far for our unsuppressed map, we created the permit statement for ACL1 to permit the 3 network to not be suppressed. And then we have the route map suppress permit 10. Actually, let's go ahead and rename that route map so that it does not confuse us. We'll do a no route map suppress, and then we will go ahead and create a new route map, which is going to be route map, and then we'll just name it any word that we want, which in this case we will name it unsuppress. Then we're going to permit our first statement, which is going to be IP address. We're going to match IP address, which is going to be our access control list, our ACL1. Okay, now let's go under router BGP 200 for R2. Now that I have my route map, and now that I have my access list that matches my unsuppressed route, which is in this case going to be the 3 network, I'm going to go under BGP configuration. We're going to do the neighbor statement 172.16.1.1. And then under here, if we do a question mark, we have an unsuppressed map option. So this is going to be a route map to selectively unsuppress suppressed routes. So in this case, if I do unsuppressed map and then the name of our route map that we just created, which is unsuppress. Again, on router 1, if I do a show IP BGP, we're just seeing the /22. And then if I hit enter on R2, and now if I go to router 1 and do a show IP BGP, nothing has changed yet. Let's do a clear on the neighbor, a soft clear. We'll just do clear IP BGP 172.16.1.1 soft. And then now let's go to router 1 and do a show IP BGP. So now, as you can see, we have done the exact same thing as we had done with the suppress map. It's just the reverse logic. We are using where the suppress map denied the 3 network from being suppressed, the unsuppressed map is permitting the 3 network. So again, the unsuppressed map is permitting the 3 network. So now if I do a show IP BGP, we can still see all the same networks. We see the /22 and the other more specific /24s as well. So that is, again, that's BGP route aggregation, and we also looked at suppressed maps and unsuppressed maps inside of BGP. Now let's just say our neighbor router 2, he has a network which is 192.168.3.0. Say that it is flapping a lot and it is causing the router, the local router, unneeded stress and CPU utilization to bounce in the routing table, to become inconsistent. What we can do in this case, where we have routes that are flapping uncontrollably like that from a neighbor, we can set up what is called route dampening on the local router. And this what this will allow us to do, as we can set our parameters for these specific networks so that they keep flapping within a certain amount of time. We can add a hold down timer or a half timer and other time limits on these routes to keep them from flapping over and over again. So the way that we are going to do this is we're going to go into router 1 under global configuration mode, and then we'll go under BGP. We'll go under BGP AS100 on router 1. I'm sorry, we're going to get out of BGP configuration mode. We'll create an access list. We're going to call this access list 3, and we're going to be permitting the 192.168.3.0 network, which is our network that keeps flapping on us, 0.0.0.255 wildcard bits mask. So we're going to permit this network, then hit enter, and we're going to create a route map on R1. We're going to call it DAMP for short. We're going to add the permit option, and we're going to match our ACL that we just created. So match IP address 3. So the next step we're going to do is we match this ACL, this network. So under this route map we have our dampening. So we can set dampening. Now this is where we can see the different options that we have in route dampening. We have the half-life. Once the penalty will be decreased 5 seconds by default. So when the penalty will be reduced in half. So in this case what we're going to do is do a set dampening to 10. The next penalty is the penalty to start reusing the route. So this is the reuse time. Pretty much saying, okay, when the route has stopped flapping within this certain amount of time period, we are going to be allowed to reuse this route. So we'll use the default, which is 750. And then our next option is the penalty to start suppressing a route. So this is the suppress timer. So once the route has flapped a certain amount of times, once it reaches this value, then this route will be suppressed and dropped, which the default in this case is 2000. And then the last value we can set for dampening is the maximum duration to suppress a stable route. So the default value for this is 4 times the half-time timer. So this is the maximum time in which we can specify for routes to be suppressed. And in this case we're going to leave it, we set the dampening to 10 minutes, so we're going to set the half-time for the maximum duration to suppress a route. We're going to set this to 40. So again, this is 4 times the half-time, or the half-life time. And so that's it. So now that we have created our route map, what we need to do is go under our BGP configuration. Again, on router 1, we're running router BGP in AS100. And we are going to set up dampening under the BGP process. We will do that by going under BGP, follow that by dampening, and then we are going to specify our route map. And next we're going to specify the name of the route map in which we created, which is damp, and then hit enter. So again, what we did is we said, since this route keeps flapping, this 3.0 is, we are going to create an access list for it, access list 3, to match this network in question, and then we're going to create a route map which is going to match this ACL and match the network in question, and then under there we're going to put our command for an action to take. So we're going to set dampening for this route. Then after that we went under the BGP configuration and we configured the command under BGP dampening route map, and then our route map that we just created, which is damp. So we're just calling our route map, and in which the route map calls the access list and performs the set action to dampen that route in question. So the next thing we're going to do is go on to router 2, where this 3 network is originating from, and we will go under interface loopback 3, look at the BGP table on R1, do a show IP BGP for the network in question, which is the 3 network. We'll go ahead and shut down our loopback 3 interface. So we'll go ahead and do a no shut. So we went ahead and flapped that route to the 3 network, and now what we can see, what we have started, we can see that there's an H next to the 3, so it is now being affected by the rules that we have set up for that network for dampening. So again, if I do a show IP BGP on the network, the 192.168.3.0, we can see dampening information penalty 948 flapped 1 time in 1 minute. So we can see this penalty start to drop. Let's go ahead and try to ping this network and see what happens. You can see that we are still successful because it has not reached the suppress limit. It has only flapped once in a certain amount of time. You can see now that the penalty is decreasing. It has decreased now to 920. So let's go back to R3 and let's drop the loopback interface again and then admin up the interface and see what happens. If I go back to R1 and do a show IP BGP, we can now see we have the H next to it like we did before. We can see that the penalty timer has now increased, and we can see that the link has flapped 2 times now. We can look more specifically at our dampening information, our parameters. For the dampening that we have created on R1, we have a half time of 10 minutes. We have the max suppress penalty, the reuse penalty, the suppress penalty. Again, we can also do the command show IP BGP dampening flap statistics. And we can see that we have the network, the 3 network, and we can see the number of flaps, which is 2. We can see the duration reuse time is 3 minutes. So let's go ahead and keep flapping this loopback interface, which is our 3 network. Now we can see if we do a show IP BGP dampening, we can still ping this network now. Now that we have 3 flaps, we still see that it has not been dampened yet. It has changed to H over on the left hand side now if we do a show IP BGP dampening flap statistics. So let's go ahead and shut this interface down again on R2 until we reach the limit, and then we should reach a limit to where if we try to ping, we are unsuccessful and the route should be now taken out of our routing table. So we created a couple more flaps on R2 by no shutting the loopback interface. And now if I do a show IP BGP for the specific subnet, we can see we have shows that it has flapped 4 times, and now we can see that it shows that a D next to it, meaning that it's been dampened. So let's try to ping it now, which is 192.168.3.1. You can see that we can still ping this route, and even though that route has flapped 4 times. If I do a show IP BGP, it's still in the BGP table, but it has now next to it a D. And we are still able to ping this network. So let's go ahead again on R2. Let's do a shut, no shut. And then let's do a show IP BGP. Now we can see a D without an asterisk next to it in the BGP routing table, or the BGP table, and we are still able to ping this 3.1 network. But if we do a show IP route, now we see the more specific route was not there. The 3 network was not in the routing table. So what we are seeing we are still able to reach that route via the /22. We are seeing the more specific route, the 3 network. We are still receiving the aggregate from the neighbor, which has the 3 network inside of it. So we are still able to ping it. So that's very tricky. So our route aggregation from before was kind of messing us up with this. Let's go under R2. I'll be right back. So what I did was I created another interface on router 2. We created a loopback 5 network to show you this, and this loopback 5 network is not part of that route aggregation that we did earlier in the lab. So now let's do a show IP BGP. We can see we added that already into BGP on R2. We are seeing that now on R1. Let's create an ACL for the 5 network. We'll just call it access list 5, and we will permit the 192.168.5.0 with the 0.0.0.255 wildcard. And then we're going to create the route map. We're going to call it DAMP5 for our loopback 5 off of R2. And then we're going to match our IP address, which is going to match our ACL, our standard ACL 5. And then we're going to set our dampening parameters to 10. Let's set this to the defaults, which is 10, 750, 2000, and then our max suppress time, which is going to be 40. So now on router 1, if I do a show, I'll go under router BGP 100, and then we will put in the command BGP dampening route map, and then specify our route map we just created, which is DAMP5. And that should be it. Okay, so now let's go over to router 2. If I do a show IP BGP, we can still see the 5 network in the BGP table on R1. Let's go under interface loopback 5 now and shut and no shut that port. So again, when we did the 3 network, it wasn't working properly because the 3 network was still covered under the aggregate or the summary route that we were advertising to router 1, which is the /22. Even though it was taken away from the routing table, the 3, the more specific network, it was still being advertised via the /22. So now if we do a show IP BGP dampening flap statistics and try to ping this guy, we are successful. So now it's coming up as being okay now. Because the reuse time has come up within that time period. So let's go ahead and shut it again and do a no shut. Go back to router 1. We can see the flaps of 1. Let's go ahead and shut it again. And then do a no shut and go to R1. We can see the 5 network is still in there. Let's shut it again. So now if I do a show IP BGP dampening flap statistics, we can see if we try to ping it, the 5.1, that route has been dampened and taken out of the routing table. We have 2 flaps now. If I do a show IP BGP, we can see the H next to it, meaning that it's being dampened. Or it is being held down. We were not able to reach that when we tried to ping it. If I do a show IP BGP dampened paths just to see, it looks like it's good now. If we try to ping this again, and we are successful. So that is route dampening. All we're doing is setting up some parameters for these networks. As soon as it has reached a threshold, it is dropping this route out of the routing table. It's suppressing and dampening the route so that it does not come back and create the router overutilization for the BGP table, the routing table, and your routing manipulation that you might be performing throughout or on your router. All these things can cause instability within your network. So that's why you do route dampening or configure route dampening. So again, to review real fast, we looked at route dampening, we looked at route suppression using BGP suppress and unsuppress maps, and we also did route aggregation. So thanks for watching the video, and I hope to see you in the next one.